Hello everyone, in this video I would like to show how to sum columns and rows in a data frame. So let's load the dplyr package, but for the first examples let's see how we can do this, the base functions. So I want to show you first of all with the matrix. So let's build this matrix. This is a 4 by 3 matrix, so 4 rows and 3 columns. Now let's sum the columns and the rows. Now I think that some people get this wrong when we use the call sums and the row sums function. With call sums, we're summing the values in each column. So this means that we're summing the values in the column 1, in the column 2, and in the column 3. So let's run. As you can see, the first result is 4, the sum of the first column, and we have 20, the sum of the values in the second column, and then we have 1000, it's the sum of the values in the third column. If we want to sum horizontally, this means that we are summing the values in each row. So this means we are going to sum the values of the first row, of the second row, and so on. In this case, we use the row sums function. Let's run. And as you can see, we have 106 for the first row, 206 for the second row, 306 for the third row, finally 106. We can also use the add margins function for this task. Add margins, first entry is the matrix, then 1 or 2, they are the margin where we apply the function. 1 refers to rows and 2 to columns. And this is the function that we want to use. In this case, it's the sum function. In this example here, basically, we are going to add a final row that sum the values in each column. So this can be a little bit confusing. So let's run and it will be. You can see now we have one final row that takes the sum of the first column, the second column, and the third column. Naturally, if we set here the row margin equal to, what happens is that we have one column here with the sum of the first row, second row, and so on. Now let's move to data frame. So let's set the M matrix as a data frame. First of all, note that we have here this default value for the column names. This is because we didn't set any value for the column names. If we use the call sums here, as you can see, this function, they work. But let's make the example a little bit more interesting, because usually when we work with data frame, we don't have only numeric value. So here I'm adding a new column, I'm calling this V4, that stores these letters A and B. And naturally, this column here is not numeric. So what happens if we use the call sums now? You can see we get an error. X must be numeric. Again, the issue is that this column here, the V4 column, is not numeric. How can we implement the sum of the columns? Basically, I want to show you step by step. We are going to use this supply function. Now, apply function belongs to the apply family function. The apply family functions are functions that implement loop. So what we are doing here basically is that we're applying the isNumeric function to the column of the data frame, each column. And note that the function, in this case is.numeric, needs to be written without the parentheses. Let's run this. As you can see, the result are true for the first column, for the second, and for the third column. Why? Because we're applying the isNumeric to the first column and this numeric, the second column and this numeric, and the third column and this numeric. But the fourth column is not numeric, so we have false as the returning value. Now, we want to basically we want to use this supply function to select the column that are numeric. And we are going to use the square bracket operator. So I already made a video about the square bracket operator, explain you how this works. Basically here, we are selecting only the true columns, basically the columns that are numeric. So if we run only this code here, as you can see now, we have selected only the columns that are numeric. We don't have the v4 column. And this means that if we run the call sums on this code here, works. Why? Because call sums uh, is working only on these three columns here. Naturally, the same it's true with the row sums. Now we have the values here, but what about if we want to add these values to the dataset? For example, we want to add this result as the last row in the dataset. For this task, we need the rbind function. Basically, we are binding the data frame with the result, this function here. But not one important point here. The original data frame has 4 columns, but this one has only 3 results, so only 3 columns. We need to add another value. In this case, I am going to add a missing value. So here I am row binding the df, the original dataset, and the concatenation of these results plus a missing value. Here you can also add for a string, for example, you could add total, but I prefer missing value, and this also will be clear in a moment why. So if we run this, you can see we have this last row with the totals and the missing value here. Now, if we want to add this total, we want to specify that the fifth column is total, we could rename the row index for the fifth row like this. Basically, the row names of the data frame, we're selecting the fifth index and we're renaming as total. Let me show you. So now you see we have this one as total. Honestly, I don't like to do this because I don't like to mix the numeric index with the character index. But this, I just want to show you how you can do this. So now we just a review here. The df here, the v4 column, we have a missing value. So if we want to check if we are missing value, we use the is.na function. Is.na, we have a missing value, and false, 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 and then we have true. So basically A, B, and B, these are not missing values. We have false. And this NA, this stands for not available, so missing value, and we have true. If you want to know exactly where this is located, we nest this function inside the which function. We run this one, you can see returns 5 because this is the fifth entry. Now let's move to the dplyr package. Let's reset the original data frame. And now, how to make the sum of the columns? Here, df is our data frame. This is the pipeline command. Then we use the summarize across where is numeric. We use the sum function. Now, across makes it easy to apply the same transformation to multiple columns, but it must only be used inside dplyr verbs. In this case, we are using across inside summarize. So basically, summarize across where the columns are numeric, we want to sum those columns. To run this code, as you can see, we have again the sum of the columns 4, 20, and 1000. What about if we want to bind this column. In this case, we use the bind underscore rows function. This is much more convenient because again we bind the data frame and we use this code here. We change a little bit. For example, as you can see here, df is outside if we use the pipeline command. In this case here, df is the first entry of the function. And this one is the same. But if you note now, we are not adding a missing value in this case. This is because the bind underscore rows function will take care of that for us. So let's run this one. As you can see, automatically is placing a missing value here. Now for the row sum, the code is very similar. So df, the pipeline command, but what you have to do here, row wise. What does that mean? Row wise allows you to compute on a data frame a row at a time. Then mutate, basically we are generating a new column that is called sum row that is equal to the sum. In this case, we have to use the c underscore across function. And this function c underscore across is designed to work with row wise to make it easy to perform row wise aggregations. So if we run this code, as you can see, we have the column sum row with this with the sum here. Now let's make a more interesting example. So I'm going to use a dataset from R. So let's run this code here, data. As you can see, this shows us all the datasets that are loaded in R that we can use for exercises, for example. I want to use this dataset, orchid sprays. Let's load, let's view it. And as you can see, this dataset is very similar to our sample because we have three columns here that are numeric and a column that is not numeric. If you want to know more about this dataset stored in R, you can use the help function, and this describes the dataset. In our case, we are not really interested in the dataset per se. We just want to apply function that we learned before. So what I'm going to do now is that I want to work on a copy. So I'm just making a copy of this dataset that is called df. The reason is that because we are going to make the same example with the package again, so I don't want to load again the data. Let's see the structure of this data frame. As you can see, we have decrease, row posts, call posts. These columns are numeric. And then we have treatment that is a factor. We can view the copy. And as you can see, this is the same dataset as this one. It's just a copy. So now, let's make the same operation that we did before. So let's sum the values in the columns and in the rows. First of all, with the base package. And notice here that I'm selecting with the bracket operator, I'm selecting all the rows and column from 1 to 3. This gives us the result of the sum of the three columns, and naturally, if we use row sums, we have the sum for all the rows here. So now you may ask why we use that supply is numeric function when we can select here the columns and we can implement the sum by using consums like this. And the reason is that when we use this selection here, we need to know which column is numeric. So let's make a little bit different example here. I am reordering the columns. So I'm placing the fourth column, the treatment column, in the first position. So let's run. As you can see now, we have treatment in the first column. Now, if I run again this one, naturally we get an error because now the first column starts for treatment. So as you can see, this is clearly a problem because if we don't know which one is numeric, suppose that we have a large data frame and we don't want to select each column, this is clearly that is best to work with the supply with this code here, because when we run this code here, as you can see, we got the results, the sums, regardless where the non-numeric column is located. But we have an issue with this function here, because if we want to append the results, so if we want to row bind this last row, we need to be careful where to place the missing value. Because if we place the missing value at the end as before, the missing value will be placed here in the last row in the call post, because always remember that the order matters in R. So in this case, because the row that is not numeric, it's the first, the column that is not numeric, it's the first one, we need to place the missing value, NA, in the first position. So let's run. And as you can see, we have the missing value here, because this is the result that we have from here, 3 rows, and we are concatenating the N here, as you can see. So we are placing basically the NA here, and then we are binding, row binding, like this. Okay, let's see before with the row sum. With the case of row sum, we don't have this problem, because we're adding just a column, a new column. In this case, I'm naming this column sum row, and this is the same function that we used. And as you can see now, we have this column here with the sum of the values. Let's do the same example with dplyr, and now we will see why it's convenient in this case to work with the dplyr package. So I'm resetting again the dataset, and as you can see, I place again the treatment as the first column. In this case, I'm directly binding the result. But if you note in this code here, I'm not placing any missing value. As before, this will be taken care by the bind underscore rows function. So this is convenient because now, as you can see, the column with the missing value is the first the column that is not numeric, the first one. So the missing value is placed in the first column. To be clear, let's rearrange again the data frame. In this case, just place the treatment, the non-numeric column, in the second position. If we run again the same code, as you can see, we got the sum and the missing value. As you can see, again, this is taken care by the function for us. So you can see that this is very convenient if we compare with the previous method with this function. Finally, we can just run again the sum of the rows here, and this is the same code as before, so I don't explain, just run. As you can see here, we have the sum of the row. So with this example, I concluded this video. I hope it is useful, and if you enjoyed this video, see you in the next one.